Right, so here is week 1 notes for unit 1 test. So make sure you know how to count significant figures and also that you know how to determine the estimate. So if I ask you to circle or underline the estimate, make sure you know how to do as such. Note of that, the estimate's always the last significant figure. Note all ALEKS questions are pre-game that are in the notes unless if I state otherwise. There are 2 ALEKS topics that I won't put on the test that I will say later in the video. This here will be given to you on the test. It will be presented as a number and you're going to have to do these things as follows. This might be something to struggle with, so I am going to do 2 examples for you. So if you're given a number, so be given a number like this, and you'll be asked to write it in correct scientific notation and I guess real notation, where scientific notation is a number and decimal times 10 raised to a power, where that number is between 1 and 9. So if you struggle with scientific notation, it is something to look into. Now, if you were given 50,500 and you're asked to round it to one significant figure, you could, again, we have to round that 50,000 to just 50,100 to 1. So the correct answer would be 5 times 10 to the 4th, or, so I would tell you 2 ways, say round it in 2 ways, or 50,000. Now, if you're asked to round it to 2 significant figures, and I can see 2 ways to do that, we would write 51, 1, 2, 3, and 5.1 times 10 to the 4th. So again, we're moving that decimal to the right of the first non-zero. And both of those are 4 sig figs, or 2 sig figs, sorry. The zeros at the end of the number are only significant if there's a decimal. Now, if we're to ask 3 sig figs, and I can see 2 other ways, 2 ways again. We could write 5.05 times 10 to the 4th again, or 50500. So I think becoming comfortable with numbers is something that is very important for you to do as soon as you can. So that this number here, 1, 2, 3, zeros in between non-zeros are significant. 1, 2, 3, zeros at the end of the number are only significant if there's a decimal. So we'll do one more. I asked you to round it to 4 sig figs. For this number, I could only ask you to do it one way. I don't see another way to do it. So we would have to write 5.050, 1, 2, 3, 4 times 10 to the 4th. So if you get asked this, notice how that exponent is always going to be the same. And keep in mind, for correct scientific notation, that decimal has to be to the right of the first non-zero. If a student wrote 50.50 times 10 to 3, so we're moving 3 times, that would be incorrect. Or if they wrote 500 times 10 to the 0 power, that would also be incorrect. I wanted in correct scientific notation or just the real number. I'll do another example with a negative number. Keep in mind that milliliter would not be on there. All right, so if you were asked, so now here we're going to have a negative exponent. We have 1.05 times 10 to the negative fourth. Now, if you're asked to round that to 1 sig fig, it would be 1 times 10 to the negative fourth, or, so if we have 1.05 times 10 to the negative fourth, I'm going to make this number smaller to make the exponent bigger. 1, 2, 3, 4. I'm going to write those zeros in. And right here, never start counting to the first non-zero. And we have to round that to 1 sig fig. So that is going to be 0.0001. These numbers are the exact same. So in a sense, I'm having you write the same number multiple times. If it's 2 sig figs, this would be 1.1 times 10 to the negative fourth. Or I could look at this number again. I have to round that to 2 sig figs, 0.0011. Oh, I missed a 0 there. 1, 2, 3, 4. And these two numbers, if I put them in the calculator, would be the same. Now, 3 sig figs. This is 3 sig figs, so be one way is to rewrite the question, but I wouldn't be that devious. Another way would be to write it in decimal form, and that is 3 sig figs as well. And lastly, 4 sig figs. We could do that 4 ways. 1.050 times 10 to the negative fourth, or 0.1231050. Both of those are 4 significant figures. So again, it's about being comfortable with numbers and maybe thinking, okay, I can always add a 0 like that. If when higher numbers of significant figures are asked, just add zeros. And notice how this exponent for every question is the same. Multiplying and dividing multiple step significant figure calculations is another thing that students struggle with. So I will do 2 examples of these. So here's an example. if I were to take 42.010 divided by 84.0 and add 0.5558. And you were asked to solve this using significant figure rules. So I struggle a bit trying to find the right words and how to explain this. So it's more so a matter of practice. As you know, we're going to solve what is in the parentheses first. If I divide those two numbers, I'm going to get 5.00119048. If you were asked just that question, you would know that your final answer would need the amount of significant figures with among the numbers with the least amount of significant figures. I didn't say that right, but I think you get what I mean. 42.010, zeros at the end are significant if there's a decimal, zeros in between, non-zeros are significant. 84.0, zeros at the end of the number, 84.0 has 3, 42.010 is 5. So if you're asked just that, your final answer would have 3 significant figures. Final answer would be 5.00. However, there is a next step where we have to add 0.5558. Now, when we add numbers, we go with the least amount after the decimal. This 5.00 has 2 after the decimal. The 0.55, so I'm going to draw a box around this here, because that's what this would round to if you were asked the answer to that question. That 0.5558 has 4 after the decimal. Therefore, the final answer should have 2 places after the decimal. We no longer need to count significant figures because we're adding or subtracting. However, we only round at the end. Therefore, these numbers, oh no, what number was that? 2.5. Therefore, those numbers, we're just going to enter. It's like we're going to enter them and then forget about them. So I'm going to add that entire number of 5.00119048 plus 0.5558. I'm going to get 1055919048. Since this number here has 2 after the decimal and the number before it has 4, the final answer is going to have 2 after the decimal. 1, 2. Even though we added these, we almost just have to ignore it. So the final answer to this is 1.06. I'm sure that is confusing. Let's do another one. 6.47 plus 0.6 times 6.88. All right, so because that's in parentheses, we're going to do that first. So if we add those two together, 6.47 plus 0.6, we're going to get 7.07. If you were asked to solve that and just that, the answer would be 7.1. However, there is more to it, and we have to multiply that by 6.88. So what we're going to do is just underline where we would normally round it, enter the full number, but know that the final answer is going to follow the significant figure rules of the numbers that we would round it if we solved it there. So we're going to multiply 7.07 times 6.88, and we're going to get 48.6416. Even though we multiplied by 7.07, we're only going to have 2 sig figs in the final answer because we only care about that 7.0. When multiplying, your final answer will be the least amount of sig figs of the numbers you've multiplied. So this is 2, and this is 3. Therefore, the final answer would be 49. So you will be asked to write measurements for using correct significant figures for different instrumentation. Remember, you're always just going to have one estimate. And if the number is right on, you are going to include a 0. For example, this was on a chemistry teacher's Facebook page, where a teacher is saying that her kids are arguing with her and whatever, saying that, okay, this would be 7.2. She's saying it should be 7.20. And her students are, I don't know, yelling at her. I blocked off her name and picture because I know this video will get dozens of views, and I don't want it. She might be crazy or something. So here, that is right on there. So that'll be 7.20, and it should have the same amount of numbers if it was right below or right above. And reading through the comments, which essentially people were just saying like, tell the kids, hey, you're a bunch of punks or something. Teachers were saying, they would accept any of those. And I can see why, because someone might read from the inside of that black line or outside of that black line there. But keep in mind, if it was right on, it's going to have the same amount of significant figures. Note, you will be asked to convert from Celsius to Kelvin or Kelvin to Celsius using one or both of those, 273 or 273.15. If I were to ask students in their class that remembered learning this in high school, or those who did learn it in high school, if their teacher used 273 or 273.15, it would probably be split down the middle. Since it's adding, one of them is going to have 2 decimal places in the end, maybe, and one of them, this one would undoubtedly have 0 decimal places. Will not be asked to convert Celsius to Fahrenheit. So that is it for week 1. Keep in mind those ALEKS questions can open there, and the hard ones I would suggest reviewing.